the relational model. So we're going to be going deeper into relational database themselves. And how a DBMS structures information is referred to as a database model or database schema, or sometimes database structure. And that's the structure for holding the data. In relational database, the schema is based on entities and relationships, or sometimes entities are going to be called class or just tables, and abbreviated as ER. So if you see ER, not emergency room, entities in relationships in this the context of this class. An entity is going to have its own fields, and entities, relationships, and the fields can have their own properties, also called the metadata, or the data about the structure of the data about the database, the metadata. For example, fields, attributes, they're going to have their own names, the data type, there's description, and so on, as we're going to be examining. So over here, we have actually right here a schema view, which is this, is the structure of the tables that are going to be created in the relational database. Notice that this is not the data itself, it's just the structure of the tables. So we need to make sure we understand the structure before we get any data into it. The data view looks something like this, something like more like the tables you might be familiar with from spreadsheet software or your regular applications like Gmail or Spotify, and so on. In the relational model, entities are tables which contain rows and columns. Columns are the fields, also known as attributes, variables, features. Kind of got to be careful because often the same things have different names. So you have to learn like all the different names to communicate among people with different domains, but that use the same technologies. Rows refer to records, also called instances of the entity. So if you have a table of courses, of classes of the university, then each record is an instance of a course. This is a course, this is a course, this is another course, and so on, just like when you see your music listed on the Spotify software, every little record is a music, is a song, or it could be a playlist. So it depends on the entity that you're talking about. But the records are instances of the entity within which it is found. Records are composed of values of the existing attributes of a table. So the values are the data values are the actual information that gets plugged in within the structure of the table. Notice that value is numeric or character, also called text-based. So value can be both character and numeric. And what often happens is that we have to translate the schema view. We begin here. We begin here, and then we move to the data view. We establish what the tables are going to look like, how they're going to be related, and then we translate that and implement the actual table structure, and then kind of a third step to add the data. There are various kinds of ways to model the database schema for the relational model. One common one is using a class diagram, which comes from Unified Modeling Language, or UML. The class diagram is similar to the ER diagram. ER diagram, once again, not emergency room, entity relationship. And it lists the entities, which are going to be translated into tables. It lists the attributes, or also called the fields. And then notice also it can be more specified, which is good. It lists the data types of each attribute. Each attribute has its own data type. And we're going to talk about what these are. Sometimes they might be written in different ways. So for example, string is one way to write it. Another usually synonym of string is character, C-H-A-R, car, for character. So depending on the program you're using, so if you're using MySQL, it's going to be car, if you're using another program, maybe you're using another database, it may be string and so on. So it depends on the, I don't know if it's actually for the Oracle, but it depends on the program you're using. But either way, a lot of people will understand this the same way. Class diagrams usually also have functions added to it. We're not going to really mess around with that, so we don't kind of need to worry about it. So we're just going to be focused on the data storage itself, but class diagram can have more. But I like the class diagram because it often has the structure to add more information that is useful. Here is a notation about the relationship, and we're kind of going to go over how to read this relationship across entities. The relational model, you can also see once again in your music programs and all sorts of stuff, all sorts of applications that we're dealing with in our day-to-day. These are the two views of another, just to kind of really emphasize the point here of the two views, the data view, where we actually see the data, although here we have to see the first, often when we have a table format, the first row may be the headers, column headers or column names, and then the rest are the records. So don't confuse the header with the rest of the records. And often programs will kind of ask you, is the first line the header or is the first line an actual record? Sometimes it doesn't have it written. So you got to make sure if in your records, in your table that you have in the list, maybe you have a comma separated value, which is a text file, kind of organized text file in this two-dimensional rows and columns. You got to make sure if you have the header there or not. But these are the records, and you can see them in the data view, but we don't see the records in the schema view, in the structure view. And usually we want to begin here because here determines what the structure of the table is going to be like, what the data type of each field is going to be. And we also determine all the information like the primary key. The primary key is the attribute that uniquely identifies each record. Oh, don't ask me to be spelled on the spot. That's a hard task. Uniquely identifies. Also, I'm sorry about the handwriting. It's so bad, but I really want to write it, but it's so bad. Uniquely identifies the record. So sometimes these are just going to be called ID. Here we have ID. You know, you generate some unique ID for each table. I'm going to need this primary key. I'm kind of going to keep going over this as we talk about databases. Okay, I'll give up. So let's take a look here also at the relationship. Often we're going to have entity. So suppose we want to get information about the states in the country. So this is a template, a schema for capturing information about states in the United States. So like New York, Michigan, Florida, and so on. And we want to have the name of the state, the number of counties of each state, the House seats within the state, the Senate seats, the governor of the state site. What is that website? Well, usually in these simple models, we're not going to have all the information here. We're not going to have the metadata. We're going to need metadata to explain, to give the description of what these things are. And so this is also important, but here we're beginning slowly. So we're just going to have some words that we should be able to understand. The regions, or the region that the state is in, and so on. Here's the data type for the value, right? Not for the name, but the data type for the value. So the values for governor are going to be character because names of governors are usually text-based. But the number of counties is going to be integer because this is always going to be a number. And we need to determine the data type, and using the best data type is best for manipulating the data and being the most efficient. So you could get away with putting character data here for the number of counties and just write out the text. but that's not good because then you can't do calculations on it. So if it can be integer, we should keep it as integer. And as we're building this database to keep track of all the state information, we also want to have information about agencies of the state. So agencies of the state, and we decide, okay, we're going to have an ID for each agency, an ID that it uniquely identifies each record, and we're going to make that the primary key, PK, primary key. We're going to talk more about that too. Primary key. And that can be an auto-generated, just auto-generated number. It doesn't have to make any sense. It's just automatically generated by the computer just to be unique so you can differentiate among the other records. The agency may have a name, may have a site like a website, or this could be an actual site like address. So once again, importance of metadata. Administrator of the agency, the phone of the agency, the state code, state name, state region of the agency. So I wanted to talk about this relationship here. Often we need to identify the relationship between entities or between tables. When you're working with a spreadsheet, you may just have one single table. However, when we're talking about relational database, we can have multiple tables and we can link them to each other. If we're going to link tables, we need to understand the table relationship. So the table relationship is based on the relationship in the real world or what you want to apply. Now, in the real world, the relationship here in this context is one to many. One to many. And that's what these numbers mean. This means one and this means many. So the relationship here is one to many. And how do we read this? Well, the number applies to the side that it is on. So or the number or the symbol. So what this means is how to read this relationship is like this. Each agency it only belongs or is related to one state. Each agency is only related to one state. That makes sense because these are state agencies, the agencies of state. So the Michigan Environment and Great Lakes and Energy Department, only of the Michigan state. It's not of New York. It's not of Massachusetts, right? It's only one. That's the natural, real relationship. Now, each state has many agencies. Each or any one state can have many agencies. So this is why, we marked here, this is a natural one-to-many relationship. Each state can have many agencies. Each agency is only belongs to one state. Okay, so here we explore this a little bit more. And what we're talking about when we're talking about relationships among entities is called cardinality. And here we're going to use a different kind of notation because this is an also common notation. Before we were using different symbols, and we'll kind of talk about both of them, but this is crow's foot notation. So let's look at the three main kinds of relationships that there are: one-to-one, one-to-many, and many-to-many. One-to-one relationship. A one-to-one relationship is where one entity is only associated with the other entity one time, and it goes both ways. And this bar over here, it looks like just a line, but it's a bar like that. It's here. This means one. So this means one, and this means one as well. This line over here. This line is the connection, and this line across is one. This is crow's foot notation. So this means one-to-one relationship. So each album can only have one description. Each description only belongs to one album, right? Each one particular description is of a particular album. We can't just take a description of one album and relate it to other albums. So this is kind of a sort of natural, I'm using this term informally here, natural, but it's a kind of a real relationship. Usually how it works is like this. Now let's look at one-to-many. We already did once. Let's look at another one. So this here, once again, this means one, this line here. Now this is the crow's foot here, and it means many. It means many. Now you say, well, there's a bar here too. Does this mean 1? Yes, because what actually happens is we have a minimum cardinality and we also have a maximum cardinality. Now, we're usually mostly concerned about maximum, and I'm going to just be focused on the maximum cardinality, like how many is the most amount of relations or connections that two entities can have. But it's good to know both as well. So how do we read this? Well, we read it, one genre can be assigned to many albums. One genre can have many albums, the many here, but one album can only have one genre. Now, this is not a kind of totally natural relationship because an album could conceivably have many genres. It can be jazz and it can be rock and it can be pop and it can be bluegrass and jazz. So this is kind of maybe not a natural relationship, but maybe in your program, you want to enforce it to be this way. You just want to assign for every album only one genre. But for every genre, of course, the genre can be associated with many albums. There should be many albums of jazz, many albums of rocks, and so on. So this is a reasonable way to structure or design a database schema for albums and genres. Now, many-to-many relationships. Here, once again, this means many, this means one. So each track can have many albums. Each album can have many tracks. Now, this is kind of awkward because a particular track is usually going to belong to one album, but it does happen that one particular song, actually the same song, the same recording, the same exact studio recording version is in multiple albums. So in that sense, a particular track can belong to many albums as well, and you may model it like that in a relational database. Oh, here is the other example of the other notation. The more related to UML and class diagram. So there's kind of 3 symbols we usually use. 0 means 0, 1 means 1, and this asterisk means many. So the way we read this is each agency can have only one state, only belong to one state, but each state can have many agencies. Now, once again, this is just the structure for the data that we are keeping, that we're recording. And we can do with it as we wish, as we want to structure the information. So I wanted just to point out how to read this over this notation here in UML and class diagram and entity relationships. Here is just kind of showing here how we see these this table format everywhere in all sorts of applications. We see on your email application, Gmail potentially, we see the rows or the records. Each record is an instance of the class. What's the class? What's the table, the entity? Well, primary emails. So each of this is a primary email, and each column here has to do with an attribute. This is the sender's name, this is the title, this is the date, and so on. And you notice that here, we're not going to see here somebody's name here. All of the columns are the same. All of the columns are date. All of these are the titles. All of these are the names. We don't just kind of mix and match. That's it for this one. Next, we're going to talk about how to design relational models.